Hello everyone, welcome back. In the last class, we have seen piezoelectric transducer. In this session, we'll see proximity sensors. I think you people have heard about proximity sensors. The proximity sensors generally used in mobile phones and metal detectors. These are the popular one. So whenever we in the smartphone, whenever we call somebody and if we put the mobile near to our ear, what happens? The screen gets off, isn't it? To save the power, it gets off. The screen will get off and you can talk. While talking, the screen is not necessary, isn't it? So the screen will get switch off automatically. There we use a proximity sensor to sense a nearer object, that is ear. Fine. Whenever you take a mobile phone to near to your ear, what happens? It senses any object there and it feels that you are talking to somebody and you need not to see a screen, hence it switch off the screen, isn't it? There we use this proximity sensors. And one more example, I said the proximity sensors are used in metal detector. Whenever you bring any metal near to that sensor, it detects. Fine, it says there is a metal nearby. There and all we can use this proximity sensors. We'll see what is the proximity sensor and how will they work and the types of proximity sensors. Fine. So we'll see what is this. What is proximity sensor? These are the sensors which are able to detect presence of nearby object without any physical contact. Fine. So as I said in the mobile phone example, you need not to put or you need not to contact the phone to your ear. If you just bring the phone near to your ear, the screen will get off, isn't it? So that is that. It is able to, these are the sensors which are able to detect presence of nearby objects without any physical contact. Fine. And these objects are being sensed is often referred as proximity sensor target. Fine. The maximum distance that is the sensor can detect is defined as nominal range. There is a nominal range. If you bring that object or a target near to that sensor, so it will detect that target, and there is a range. You cannot expect you keep that metal 1 meter away and you cannot expect that sensor to detect that metal. Fine. There is some range. If you bring that material near to that range, it will detect. There are different types of proximity sensors. The first one is eddy current proximity sensor, and the second one capacitance proximity sensor, and the third one inductive proximity sensor, and there is one more, fourth one pneumatic sensor. We'll see one by one. What is eddy current proximity sensor? So in EMI current proximity sensor, again proximity sensor, it will detect the nearby object, isn't it? So how it will detect, how the eddy current proximity sensor will detect the object? So there are totally two coils here. One is active coil, that is the main coil, and another one is a reference coil. Fine. When this active coil is supplied with the alternating current, an alternating magnetic field will be produced. These are the magnetic field. Whenever you supply AC current to this active coil, it will give magnetic flux. Fine, or magnetic field. If there is any metal object in close proximity to this alternating magnetic field, let's consider this is the target, whatever we are seeing here. So this is the target which brought near to that magnetic field. Fine. Then this target will produce a eddy current inside this coil. Fine. The eddy current will be induced in the coil. Hence, the impedance of the coil will change, thereby changing the amplitude of the alternate current. So whenever we supply alternating current and it produces a flux. When you bring any target material near to that field, what happens? Eddy current will produce and the impedance of this coil changes, and thereby it changes the amplitude of the AC current. Hence, there will be a change in an impedance as well as a change in amplitude of the alternate current. We can say that there is an object near to the sensor. Fine. Okay, we'll see what is the advantages of eddy current. Now, eddy current proximity sensor. Then definitely it is non-contacting measurement, because this target is in not contact with this sensor. Fine, there is a distance between. Fine, it is a non-contacting measurement. It has got a high resolution and it gives or it shows high frequency response. So what is disadvantage of eddy current proximity sensor? The effective distance is limited to close range, that is nominal range is less. Fine. And the relationship between the distance and the impedance of the coil is non-linear and temperature dependent. That means if you bring this target to very near to this sensor, or somewhat far from this coil, what happens? The impedance is not linear with the distance. Even though you keep the target here, or if you bring the target still nearby, what happens? There is no linearity in a change in impedance. Fine, that is one disadvantage. And third one, it only works on conductive material with sufficient thickness. So the target should be conductive material and it should have some thickness. Fine, less thickness material or non-conducting material will not work with the eddy current proximity sensor. Fine. Next we have a second type of proximity sensor, that is capacitive sensor. Capacitive proximity sensor. As you can see in the diagram, the capacitive proximity sensor, it is just like a ordinary capacitor, whereas the capacity of two plates is detected. So one of the plate, which is the object to be measured, is the sensing object and it is imaginary ground. Another is, so this is the one plate, this is not plate, actually this is a sensing object and this is actual plate or a actual sensor. Fine. So this is the object to be measured and this is the plate of a sensor capacitor. The change in the capacity will be generated between these two poles are detected, and the object that can be detected depend on the dielectric constants. You can see here the capacity or the amount of capacitance varies depending on the size and distance of the sensing object. Fine. So whenever there is a sensor which has one plate here, whenever you bring any object near to that sensor, what happens? There is a capacitance or the voltage difference will happen here, since the sensing object is imaginary grounded. So the voltage or the capacitance is vary depending upon the size of the object and distance between these object and the dielectric material between this object. Fine. And the third one, inductive proximity sensor. In the inductive proximity sensor, what happens? There is a core and the coil wound around that core here, and that is connected to this oscillator and level detector and output switching. What happens? Whenever any metal whenever we bring any metal near to this inductive coil, what happens? The change in the inductance happens. This leads to change in the oscillator circuit. That is, this can be monitored by oscillator circuit here, and this change is used to trigger a switch. Whenever you bring any metallic material near to this inductive coil, the inductance of this coil changes, then that will make this circuit to behave differently. That is how we detect a nearby object. Fine. And the fourth one, pneumatic sensor. In the pneumatic sensor, what happens? There are two cases given here. One, this is a pneumatic sensor without any object near here. There is no object near here, and there is one pneumatic sensor. We have one object. Fine. This is object. Two cases. Fine. Without object here, with object here. What happens here? Without any object, the low pressure air will flow through this port and pass through this port freely, and the pressure will be distributed, and there will be a normal pressure will be produced at a port P, isn't it? In case where we bring any object near to that pneumatic sensor, what happens? Whenever low pressure air flows through a port A, and that air falls onto this object, and it puts the pressure on a port B. The amount of pressure it puts is depending upon the object distance, isn't it? So hence we can say, if there is a more pressure on a port B, we come to a conclusion that there is an object nearby. If there is no pressure that happen, then what that mean? That means there is no object nearby to that sensor. Fine. This is how pneumatic sensor will work. Next we have digital optical encoder. The figure you can see here, this is the digital optical encoder. So what is digital optical encoder? It's a device which converts motion into a sequence of digital pulses. Fine. So that the motion can be a linear motion or a rotary motion. Fine. It converts that motion into sequence of digital pulses. By counting a single bit or by decoding a set of bits, the pulses can be converted to relative or absolute position measurements. Okay, and you can see the diagram. That is the incremental encoder, which produces a digital pulses as the shaft rotates. It allows measurement of relative position of the shaft. Fine. So these rotary encoders are composed of glass or plastic core disc with photographically deposited radial pattern. That is, it is the disc that can be plastic or a glass disc and photographically radiated. What is that? Photographically deposited radial pattern organized in track. You can see the diagram. Those photographically deposited patterns are organized in tracks. As the radial lines in each track interrupts the beam between the photoemitter and detector pair, and digital pulses are produced here. Fine. So there are light emitters here and the light detectors here. Whenever these light emitters sends the light through these tracks, what happens? This light will detect, and depending upon the layers of this photographed particular tracks, what happens? The light will be detected, and these are of different category. Fine. And there are three tracks, that is inner track, middle track and a outer track. Whenever the rotary motion happens, the outer track will move first. Fine. So this is just like a clock hands. Okay. And when what happens when the disc rotates in clockwise direction, the pulses in the outer track leads and those in the inner. Fine. In the counterclockwise, it lags behind. Fine. This is how this optical, what is that? Our digital optical encoder will work. Next sensor is PIR sensor. Fine. What is PIR sensor? Passive infrared sensor. So generally what happens? All objects with a temperature above absolute zero will emit heat energy in the form of radiation, isn't it? So above 0 degrees Celsius what happens? So every body will emit some energy, and that energy is in the form of IR radiation, fine, infrared radiation, that the wavelength is in the range of infrared, but it can be detected, the bare eyes will cannot see that infrared, but it can be detected by electronic devices designed for such purpose, isn't it? The passive infrared sensor, that is a PIR sensor, is an electronic sensor that measures infrared light radiating from object in its field of view. And the PIR sensor is also known as the passive infrared or pyroelectric or IR motion sensors. Fine. These are also called passive infrared or pyroelectric sensor or IR motion sensors. Fine, both are same. The working principle is same there. The PIR are basically made of pyroelectric sensor. What is that pyroelectric sensor? Which the same figure which shows is a pyroelectric sensor which has a round metal can with a rectangular crystal in the center. Fine. So that is pyroelectric sensor which can detect levels of infrared radiation. The PIR sensor itself has two slots in it. Each slot is made up of special material that is sensitive to IR. Fine. The lens used here, you can see the lens in the diagram, that is used here to consist of two slots that can see out past some distance. When the sensor is idle, the both slots detect the same amount of IR. When a warm body like a human or an animal passes by, it first intercepts one half of this PIR sensor, which causes a positive differential change between the two halves. Fine, two halves. When a warm body leaves the sensing area, the reverse happens, whereby the sensor generates a negative differential change. This change of pulse is what is detected. You can see in the diagram here. Fine, these are the pulses detected by that animal or a human being. Fine. And what is the applications of PIR sensor? You can use outdoor light for outdoor light. Fine. Lift lobby, multi apartment complexes, common staircases, for basement of a covered or parking area. You can use in a shopping mall. The main features of this PIR sensor is the low noise and a high sensitive. The supply voltage is only 5 volt is enough. Delay time is adjustable, and the output is standard TTL output. So this is how the PIR sensor, this is what the PIR sensor features. Fine. So it generally detects the temperature or temperature of a human body. We can use to measure the temperature of a human body. We can use the PIR sensor, because the human body generates when human body is always produces some heat, isn't it? So heat in the form of infrared rays that we can detect, and we can calculate the temperature. Fine. And with this we have completed the second chapter, that is unit 2 of EMI. Thank you so much.